Hello, this is Klaus from Lemonade, and today I'm going to show you how I use the vehicle scene graph node in Lemonade to realize the Mars Rover from the game Mars Lags. For that, we're going to look at the general scene graph setup, then we're going to go through how the individual nodes are configured, and last we're going to look at some code to see how the rig is operated at runtime. But before we start, if you'd like to remix your own Lemonade project with this very rover model, you can go ahead right now and find it as a prefab asset, rigged and complete with control scripts in the Lemonade Asset Store. Just search for Mars Rover. Looking at the scene graph, we can see the vehicle node itself right here. And before we go into its configuration, let's first note that it has 7 child nodes, one of them representing the main body or chassis of the rover. And then we have 6 child nodes representing the 6 wheels of the rover. Let's also note that these child nodes all are simple mesh nodes, and that the wheel mesh nodes all have their physics actually turned off. When setting up the wheel nodes, it is worth noting that the only thing they contribute to the actual physics simulation is their position. Let's see what happens when we change it. We can see that the physics simulation now thinks that the wheel is actually mounted at a different position. On the other hand, when we change the rotation or scale of this wheel node, oh, this looks really weird. Anyway, we can see that the physics simulation ignores this scaling and rotation and behaves as if the wheel was still in its original position and orientation. Moving on to the chassis node, we can see that it has its physics enabled, and the most important factor that we have to control here is mass, which represents the mass of the entire vehicle. Now let's have a look how the actual vehicle node is configured. Among its node-specific fields, we first have a reference to the chassis node, and then we have a section of fields relating to all of the wheels. 6 wheels, so we have 6 sections, and we can add more wheels if we want to, but right now 6 is all we want. And for this rig, actually all the wheels are configured identically, so I'm just gonna look at one of them. Now each wheel section first contains a reference to the respective wheel node. Then there is 4 parameters that model how the suspension for this wheel is gonna behave. Then there is 2 parameters controlling how forces are exerted through this wheel. Then there's a parameter describing how large the wheel is. And the last 3 parameters control how much force is exerted onto the vehicle through this wheel and in which direction the wheel is pointing. Those last 3 parameters are usually changing at the runtime, that's why they are controlled via script, and we will look at this later. For illustration of these other parameters, let's see what happens when we change some of them. For example, compared to this nominal setup here, let's see what happens when we increase the suspension rest length for the front left wheel. And we see that the vehicle now rests far higher above ground in the front left corner. Let's change another one. Let's make the wheel bigger. And again, we see that the simulation now acts like the wheel is much larger and it also rotates slower compared to the other wheels. And naturally, you would need to adjust these parameters to fit the proportions of your individual rig and to model its desired behaviors. Now, finally, let's look at how to operate this rig at runtime. And we do this by changing these last 3 parameters. And for that purpose, the API offers us for the vehicle node these 3 functions: set steering, set brakes, and set acceleration. They all accept a table which contains a value for each of the wheels, which are identified by this index. Set steering determines which angle the wheel is pointing at this time. Set brakes says which braking force should be applied through this wheel. And set acceleration determines how much acceleration force should be applied. Now let's see how we apply this for this specific rig. For example, if we wanted our rover to rotate to the right, we see that we need to angle the corner wheels at 45 degrees, then have the left-hand side wheels push forward and the right-hand side wheels push backwards. Now let's see how this looks in the code. Steer to turn calculates a steering angle, which is then passed for the 4 corner wheels, and for 2 of them it's actually passed as a negative value. And for the 2 center wheels, we pass a steering angle of 0 because we want them to keep pointing straight forward. Then we call accel to turn left with a negative factor, which calculates an acceleration force, which is then passed for all of the 6 wheels, except that for the left-hand side wheels, it's passed as a negative value. Last, we don't want to brake, that's why we call apply brakes with 0, which will apply a braking force of 0 for all of the 6 wheels. And this is how you create and operate a custom vehicle rig in Lemonade. Thank you for watching.